Alright, so 5.1 is properties of exponents. A monomial is an algebraic expression consisting of one term, such as x, 2x, negative 3x squared, as long as there's no plus or minus. That would be a binomial. So this is all straight review. The product of properties rule, product of powers property. I can speak, which is not a good day. Okay, so first off, this is if I have x to the a times x to the b. This is the old keep the base, add the exponent. So that's going to be x to the a plus b. Now, real example of that would be maybe x cubed times x squared would be 3 plus 2 x to the 5th. Now, power of a power. Power is exponent. So if we have something raised to a power, or an exponent, like x to the a, but then we raise that to another power, a b, well, we multiply a times b. So another example, if we have x cubed, that's a power, but then we take that to another power, we multiply in this case, and we get x to the 6th. Power of a product. Well, that means we're just going to have a product like x times y. Could be more complicated, but x times y. And if we raise that to a power, basically you got to remember that this has a power of 1, this has a power of 1. We're going to do the same thing as previously. We're going to multiply, except in this case we multiplied everything inside the parentheses. So that's going to be x to the a times b to the a. So for example, if I had 2 times x to the 3rd, that's a 3. Just go with it. Let's try it here. It's a bad 3. Let's make it then y squared, just to make it exciting. Okay, if we took that to a power, let's say 2, we got to remember that this is really a 1 here. That's the most common mistake. We've been talking about this for months now. Don't forget to distribute this 2 to the number, not just the variables. So in this case, that's going to be 2 to the 2, x to the 3 times 2, as we just learned, 6, and y to the 2 times 2, 4. And when we can, we always want to simplify our numbers. So 2 squared is 4, and then just x to the 6th, y to the 4th. Negative exponent. We've talked about this before also. We don't want to ever have negative exponents. Ever. So this is the story about when you're babysitting. Talked about this before. You're upstairs. You've got the kids. They're being brats. What do you do with them? Tell them to go downstairs. Quiet down. Get a better attitude. So x to the negative a, that's really, you don't have to write this, but that's really upstairs. So we are going to send them downstairs to get a better attitude. Okay, so that'll sound good. So we have x to the negative a, send it downstairs to get a better attitude. 1 over x to the a. And it works the same way if the negative exponent is on the bottom. Well, this is supposed to be an x. Let's say I have 1 over x to the negative a. Well, downstairs, being bad, what do? Send them upstairs to get a positive attitude. So those are equivalent. So an example of that, 5 to the negative 2. Well, that's upstairs. What are you going to do? Send it downstairs. 1. Base doesn't change. Exponent just becomes positive. So that's 1 over 25. So 5 squared is 25, then it moves downstairs. Okay, the zero exponent property is very easy. Anything to the 0 is 1. It doesn't matter how small, how big, how simple, how complex. Anything raised to the 0 is 1. So I could have a fraction, something like 1,372 x y to the 4th over z, all that, plus 2, whatever. If I put it in parentheses, this whole monster of a mess raised to the 0, it's 1. Doesn't matter. As long as this whole quantity is raised to the 0, it's just 1. Quotient of powers property. Well, that's kind of like product, except we have a fraction. So in this case, if we have x to the a over x to the b, in this case we keep the base and we subtract the exponents. So if I had 5 to the 7 over 5 to the 3, and we can use this with letters or numbers. Well, 7 minus 3 is 5 to the 4. And then that would be 625. Okay? I personally don't like the subtraction rule. I like to just say, where do I have more? And you've heard me say this before. Where do I have more 5s? At the top. How many more? 4 more. And the reason I don't like this rule is because what if I had this? You know, x to the 1 over x to the 5. Well, technically, we should do 1 minus 5 and get x to the negative 4, and then we have to move that downstairs. Just seems like more work to me. Simple question. Where do I have more x's? On the bottom. How many more? 4 more. Boom. Done. It just seems to me to create more work to subtract it than move it. I just like to do it that way personally. Okay, power of a quotient. This is when you have something like x over y, and you have that taken to a power. Same as we've already done. This is 1, this is 1. So we're going to take that and multiply it in, take this a and multiply it in, so we get x over a, that's an x, over y over a. So for example, if I had 2/3, I square that, well, this is 1, that's 1. So 2 times 1 is 2 to the 2, over 3 times 3 to the 1, 1 times 2, 3 to the 2. So you're just doing 2 times 1 here, and 2 times 1 there. And that leads us to 4 over 9. Bad 9. Okay, this is a rule we've been talking about plenty this year. You cannot distribute an exponent if there's a plus or minus. Basically, if it's a binomial. So we've talked about this over and over and over again. X plus y, in parentheses, binomial, squared, is so not x squared plus y squared. You cannot do this. It's technically x squared plus 2xy plus y squared. You cannot just send the 2 in across this plus sign. Big no-no. Talked about it all year. Okay, so in this case, we're just taking this 5 halves and we're going to multiply it by 3 and by 12. Now remember, we don't multiply the 3 times 5 and 2 because this is really 3 over 1 times 5 over 2. So that's 2 to the 15 halves. And x to the 5 times 12 is 60, divided by 2 is 30. Now in this case, you can keep this 15 halves because it doesn't work out real nicely. It's a decimal. But remember what this really means. This means the square root of 2 to the 15th power. If this were a 9, you could do that. Square root of 9 is 3. Take 3 to the 15th power. It'd be a huge number, but you could do it. But if it's something awkward like that, you can leave it. Okay, number 2. This is a 1. That's a 1. We're setting the 2 in. 3 squared over 4 squared. So 3 squared is 9. 4 squared is 16. We're done. Now, number 3, you have 2 choices. You can send this 3 in here and this 3 in here and get x cubed over 3 cubed. But you got to remember that it's still being raised to the 2. And then you got to send this in here and this in there. That's one way to do it. Another way to do it is just take this 2 times the 3 and make that 6. And then you just got to send the 6 in. You get the same answer no matter which way you go. So it really makes no difference to me which way you do it. X to the 6th over 3 to the 6th. So that leads to x to the 6th over 729. Final answer. So once again, you're going to get the same answer. Technically, 3 cubed is 27, and then 27 squared is 729. So you're going to go and get the same answer no matter which route you take on this problem. Okay, number 4. Key thing to remember here is this is a 1 in front of the x. We don't usually write it. You don't have to. But we're going to do numbers times numbers and variables times variables. So negative 2 times 1 is just negative 2. Now here's a huge point. We're not moving the negative 2 downstairs. It's not a negative exponent. We don't move negative numbers. We just move negative exponents. This stays. A lot of people are going to want to put this as 1 over 2. And move it downstairs, make it positive. We're not doing that. Only negative exponents. Now, here we're multiplying. So we're going to keep the base and add the exponents. But we cannot add 7/4 and 4/3 because they do not have a common denominator. We can't do this right now. So we have to find a common denominator, which is 12. So 4 times 3 is 12. So 7 times 3 is the infamous 21. And 3 times 4 is 12, and 4 times 4 is 16. So 21 plus 16 is 37, and that's going to be over 12. And we can just leave it just like that. Okay, number 5, very simple. 2 ways to go about this also. Neither one is right or wrong. So that's a 1. We're going to send the 2 in. So that's going to give me r squared. And if I send the 2 in here, that's going to give me s to the negative 10. But I cannot have a negative exponent, so this bad boy is going to get moved upstairs, which gives me r squared s to the positive 10. And there's really no need even for a fraction bar anymore because there's nothing on the bottom. That's one way to go about this. Another way is, how about just moving the s right off the bat? R1, move the s up. And then that is being taken to the 2. Send the 2 in here. Send the 2 in here. You get the same answer. It's just 2 different ways to go about it. Not one right, not one wrong. Okay, here's what I was talking about before. Even though there's not a 1 here, most of you will probably send the 1/3 to that because you're used to setting it to variables. But the most common mistake is to want to not send it to the negative 64. This gets the 1/3 also. It goes here, 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 and here. So we're going to write negative 64 to the 1/3 power. If you need to, because of calculators, you might want to remember to put that in because it's the whole negative 64. Then it gets real easy. A to the 9th, 9 divided by 3 is 3. B to the 6th, 6 divided by 3 is 2. You might say, why are you dividing by 3? Multiplying by 1/3 is the same as dividing by 3. And then C, 1 times 1/3 is just simply 1/3. Now, you can put this in your calculator, or you can just think about the fact this is the same thing as the cube root of negative 64. Which means we're going to have a negative answer. And it's going to be negative 4. Now, one thing I want you to be careful about here is there's no I. Why is there no I? Because we're not doing square roots. You can take the cube root of a negative number. It's totally okay. Negative 4 times negative 4 is positive 16. Times another negative 4 is negative 64. Cube roots of negatives are okay. Moving on. A lot of choices here. But the first thing you definitely have to do is send this 3 in, no matter what. You want to get rid of all the parentheses. So that's going to give me 2 cubed. If you want to write 2 cubed and write it again, or if you just want to write 8, that's up to you. X to the 6th. And that's going to be over 5. Times 15. Now, when I'm doing this, I personally like to kind of just clean stuff up right as I'm writing it. So I'm going to move these downstairs because I have a negative exponent. Now, I already had 3 x's down there. I'm moving 2 more. That's going to give me x to the 5th right here. And then my y's, I'm going to clean that up. Where do I have more y's? On top. How many more? 1. Now I have a couple choices. I can multiply straight across, or I can cancel. I personally like to reduce my numbers and keep them small. So I'm going to say 5 goes into 15 3 times. And 2 goes into 8 4 times. Now I'm going to multiply it. 4 times 3 is 12. X to the 6th. Y to the 1 over x to the 5th. And again, I ask myself, where do I have more x's? On the top. How many more? 1. And I get 12xy. Now, you didn't have to do that. If you wanted to do 8 times 15, go for it. 120. 5 times 2, 10. 120 divided by 10, bam, 12. We could have done 6 plus negative 2 is 4. Still, it would have worked out. Where do I have more x's? On the top. 1 more. So there's a whole slew of different ways of going about problems like this. Okay, get ready for some fun. So the negative 2 is going to get sent in to everything. There, 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 and here, here, and here. It's just going to be a negative 2 fest. So 4 to the negative 2. X to the negative 4. Because 2 times negative 2 is negative 4. Y, negative times negative is positive 6. All over, again, 2 to the negative 2. X to the positive 4. Why? Because negative 2 times negative 2 is positive 4. And then y to the negative 2. Now at this point you have choices. You can just move everything. It's up to you. So 4 to the negative 2 is going to come downstairs to become 4 squared or simply 16. 2 to the negative 2 is going to go upstairs, 2 squared or just 4. Now my x's. These 4 are going to go downstairs and join these 4 and become 8. These 2 y's are going to go upstairs and get positive and become y to the 8th. And I'm almost done. I just need to reduce 4 over 16 to 1 over 4. And then y to the 8th, x to the 8th on the bottom. And that's it. Last but not least, 4 and negative 12. 1 over negative 3, just reduce it. X is 7/3, X 1/3. This is nice. They're both thirds. Where do I have more X's? On the top. 7/3 minus 1/3 is 6/3, or just 2. If you need that baby step, you can, write it over here, or you can write it and do another step. It's up to you. 6/3 is 2. Now, on the Y's, I cannot combine these because I don't have a common denominator. So I'm going to change this to 10/4. So I have a common denominator with 1/4. Now, where do I have more Y's? Still on the top. 10/4 minus 1/4 is 9/4. And I can just leave it like that. And that's my answer.